So in the last interaction we have completed up to which topic? I think in the last interaction we have completed up to thermal gravimetry and gravimetry. Yes or no? Deliquescent substance already completed, na? Yes, deliquescent substance already completed. Next is gas also Carl Fisher titration is also completed. So after Carl Fisher titration, now we are going to learn the gas chromatography. So what is gas chromatography? First of all, in this chromatography, the sample should be volatile. Why the sample should be volatile? The reason behind that is it's gas chromatography. So volatile means if we convert this sample into vapor form, then it will definitely become gas phase, yes or no? So then we can complete the chromatographic method and all these things. That's why okay, let's start. So next is gas chromatography. Gas chromatography. The most important point in gas chromatography is sample, type of sample and principle. What is the principle? So sample should be which type of sample? Volatile sample should be there. Why volatile sample? Because it is the type of gas chromatography, and gas means if liquid is there, then if we put some temperature heat and this liquid converts into gas, that is vapor. These vapor are in gas form, yes or no? So these vapors are in gas form, and this liquid, if it is volatile, then only after applying some temperature or heat, this liquid will convert into vapor, and these vapor are in gas form, so we can easily do the chromatographic technique. So that's why sample should be volatile. Number two, which type of principle? There are two different types of principle are there. One is adsorption, another one is parts it's partition coefficient, yes or no? So mainly two different types of principles are used in chromatography, that is adsorption and partition coefficient. So always remember, partition coefficient will be in the case of solution, volatile, and all these things, like liquids, in the case of liquids, whereas adsorption will be in the case of solid and liquid, or solid and gas. This, for example, a substance is there, solid substance, so what will happen? Gas will be adsorbed on this substance. It's for example, consider it's a part of sponge. So sponge will be porous like this, na? So when it is porous, it has more surface area. So on this sponge, gas will be adsorbed or liquid will be adsorbed like this. Again, when you press the sponge, oil will come out. So this is adsorption in the case of solid and liquid, or in the case of solid and gas. In the case of solution or only liquid, like if both the phase are liquid, then in that case we will the principle mainly will be that partition coefficient. Okay, so which type of principle will be used in the gas chromatography also? So in the gas chromatography also, partition coefficient will be the principle. Okay, so next most important point, what are the different types of detectors? So detectors used, right now we have to complete that topic fast, so I am only mentioning the important points, okay, the points which are very important for the competitive exam. So there are for mainly ECP, FID and FPD. So you have to remember ECP, FID, FPD. ECP, FID, FPD. Okay, what is ECP? ECP is electron capture detector. Next, FID means flame ionization detector. Okay, next is FPD. FPD means flame photometric. Oh, okay, wait. ECD, then FID, then FPD. So ECD is electron capture detector. FID means flame ionization detector, and again FPD means flame photometric detector. Okay, so there are mainly three types of detector used in gas chromatography. Okay, also another very important detector is there, that is also called TCD. TCD means thermal conductivity detector. So you have to remember these four types of detector. Okay, let's please repeat after me. What are the different types of detectors used in the gas chromatography? Mainly four types of detector. What are they? ECD, FID, FPD and TCD. So what is ECD? ECD is electron capture detector. What is ECD? ECD is electron capture detector. In this, current will be flowing. And what is current? Current is the flow of something is called current. If the flow of electron, then it is called electric current. If the flow of water, then it is called water current. Like tide, it is also called tide in the river. Okay. And if the flow of wind, it is called wind current. Wind means air. So flow of something is called current. So ECD, in this what will happen? Electrons will be flowing, generating the current, and this electron will be captured in the detector, which will ultimately give us the result. Okay, so this is called electron capture detector. Next, flame ionization detector. In this, high intensity flame will be used, and it will ionize the air surrounding it, and this air will again, after ionization, it will also cause the flow of something. Ultimately it will also cause the flow of current, and this will be again detected in the detector. So this is flame ionization detector. Then flame photometric detector. In this, photo means photo. What does photo mean? Photo means like this, you will find the energy. These are called spectrum of energy. Okay, this spectrum of energy, when all this spectrum will fall together on a surface, it is called photon. So you might have found that photon in the Newton's law. Yes or no? So these photons are the spectrum of different energies. Okay, for example, when sunlight is falling, these sunlights are made up of different photons. Yes or no? These photons are made up of, all these photons together make spectra like this, and this spectra will fall on the surface of the earth. Okay, so photon means, this comes from the word photon, which is related to energy, and this energy will again ionize the radiation. This energy will again ionize the metric detector. So this photon which contains energy, this energy will again, what will it will do? It will ionize, and after ionization it will radiate some electrons, and this electron will be again detected in the detector, and which will give us the result or the final result. Okay, next is thermal conductivity detector. In thermal conductivity detector, for example, one rod is there like this. If you put this side of the rod on the fire, what will happen? After a few minutes, that side will also be hot. Yes or no? Why? Because of the conduction of heat. This conduction is also the different types of current are there. Okay, ultimately flow of heat. The flow of heat is called heat current, and this heat current will cause the conduction of the heat from one side of the rod to another side of the rod. By this way current will flow, and again it will be also detected in the detector, okay, which will later be analyzed, and we will get the graph, different types of graph we will get. Okay, already I told you earlier that two types of polymorph are there. What are they? One is amorphous. What is the other one? Amorphous and crystalline. So this crystalline will give which type of peak? Sharp peak. This is sharp peak. This sharp peak will be given by the crystalline, and this amorphous will give which type of peak? Broad peak like this. Okay, so these are the sharp peak, okay, and these are the broad peak. But this peak, this graph is found from analyzers, which will analyze, and again finally it will generate the graph. Okay, so next important point here is that, so in the gas chromatography, what we have learned in the gas chromatography, first of all, the substance should be volatile. Yes or no? The substance should be volatile. What are the substance? Simple substance. Number second is principle. Which principle is acted on the gas chromatography? That is partition coefficient. Next, third point is detectors. What are the different types of detectors are found in the gas chromatography? 4 types. They are thermal conductivity detector, electron capture detector, flame ionization detector, and flame photometric detector. Thermal conductivity detector, flame ionization detector, flame photometric detector, and electron capture detector. Okay, these are the most important points on gas chromatography. That's it. Next, we are proceeding further towards the thermal gravimetric analysis. What is thermal gravimetric analysis? So gravimetry means in this gravimetry what will happen if X has a weight or W1, okay, and after 24 hours of weight, 24 hours, what will happen? It will absorb some, sorry, not W1, this X. X is a substance, for example it's a tablet, and it will absorb water, moisture from outside environment. Why? Because it is hygroscopic. And what is hygroscopicity? Hygroscopicity is the tendency of absorbing the water or water particles from the outside environment. What we are doing? Ultimately, what is gravimetry? What is gravimetry? And before that we studied also gas chromatography. What all these things are? Gas chromatography, gravimetry, these are the methods by which we can detect the amount of water absorbed by a substance from the environment. So these are the gravimetry are the method by which we can detect the amount of water. We can detect the amount of water which is absorbed by a substance from the environment. Yes or no? So that's why what we are doing here in the gravimetry, we will also calculate the amount of water. So for example, X is a substance which has weight W1. X has a weight W1, but after 24 hours it has weight W2. Why? Because of absorption of water particles from the outside, the weight will increase. Already I have mentioned earlier this. After the absorption of water from the surrounding, the weight will definitely increase. So weight is increased from W1 to W2. In that case, percentage weight change we will detect by W2 minus W1 upon W1 into 100. So simply it is called percentage change. So by definition you can write that percentage change equals to right, percentage change of weight is equals to final weight minus initial weight upon initial weight into 100. Final weight minus initial weight upon initial weight into 100. So this is percentage weight change. By this way we can define the percentage of weight change in a substance. So why the weight will change? Because it will absorb moisture or it will absorb water particle from outside. Due to absorption of water particle, first it was like this, but after absorption of water it will be like this. Weight was 1.2 gram, 1.2 gram. Now its weight will become 1.6 gram. So this is the percentage change. So in the question they can also ask that a paracetamol tablet which is kept on the environment open for 24 hours. A paracetamol tablet which is kept on the environment open for 24 hours. So after 24 hours, so initially the weight of the paracetamol tablet was 1.2 gram. And after keeping on the open in the environment for 24 hours, the weight of the paracetamol became 1.6 gram. So what is the percentage change? They will ask the question like this. So question, what is the percentage change of weight of paracetamol? How can you define that? So now we will do like this. Percentage change equals to percentage change of weight equals to final weight minus initial weight upon initial weight into 100. So what is the final weight? Final weight is 1.6 minus what is the initial weight? 1.2 upon initial weight 1.2 into 100. So what's that? 1.6 minus 1.2 means 0.2 upon 1.2 into 100. Point cancel. 2 by 12 my 1 by 6. 1 by 6 into 100 means 16.8. 16.8%. So percentage weight or percentage weight change of the paracetamol is 16.8%. So by this way they can also ask the question. What was the question? A paracetamol tablet was kept open in the environment. The initial weight of the paracetamol tablet was 1.2 gram. After 24 hours the weight of the paracetamol was 1.6 gram. So what is the percentage weight of paracetamol? So by this way you can calculate that. Okay, thank you. Next is that you know what is anhydrous, hemihydrate, monohydrate and dihydrate. Anhydrous, hemihydrate, monohydrate and dihydrate, these are very important. See, a drug will be made up of all. In the morning we already learned that a drug substance is made up of two things. What are the two things? One is active pharmaceutical ingredient or drug substance along with saturated salt solution or excipients plus active pharmaceutical ingredients. These two will make a complete tablet. Yes or no? Now this tablet has initial weight 21, initial weight W1. After 24 hours its initial final weight become W2. Okay, then what is the drug substance? So drug substance, if 0 molecule of H2O is added means this tablet absorbed no water from the outside environment. Tablet absorb no water. Tablet absorb no water molecule or particle from environment, then it is called anhydrous. It is called anhydrous. If 1/2 molecule of H2O is added, then it is called hemihydrates. Hemihydrates. If it absorbs 1 molecule of water, then it is called monohydrate. And if it absorbs 2 molecule of water, then it is called dihydrate. So what is hemihydrate, what is monohydrate, what is dihydrate? Yes, it is called dihydrate. Okay, so what is hygroscopicity? If the tablet absorbs water from the outside environment, the tendency of a substance to absorb water particles from the outside environment is called hygroscopicity. And the percentage weight or percentage change of weight is calculated by final weight minus initial weight upon initial weight into 100. Here is the initial weight. After 24 hours, here is the final weight. Okay, so final weight minus initial weight upon initial weight into 100. This is the percentage change of weight. And what is that? If after calculation we will get the percentage change of weight, yes or no? This percentage change of weight will denote the different absorption of water inside the drug substance. Okay, so if the drug substance absorbs no water, 0 molecule of water, then it is called anhydrous. If the drug substance absorbs half molecule of water, then it is called hemihydrate. If it absorbs 1 molecule of water, then it is called monohydrate. If it contains 2 molecule of water, then it is called dihydrate. Okay. Next, solubility of anhydrous substance is higher than that of hydrous form. You have to remember that. But in a note, you have to remember that solubility of anhydrous substance is more than that of hydrous substance. Solubility of anhydrous is more than that of hydrous substance. Okay, next, what is fine particle characterization? Fine particle characterization is related to the size, shape and surface area. Okay, for example, if you take substances in larger size, then they will have, if for example you are preparing a drug, a tablet, in this tablet you have to take the substances in very small minute particles, in fine particles. If they are in large size, then you should break them into fine particles. So by using ball mill, hammer mill, crushing and all these things. Okay, so fine particle characterization is mainly related to size, surface area, shape and morphology, and shape and surface relation, shape and morphology. Okay, so these are mainly related to fine particle characterization. Okay, so for example, size is determined by static and dynamic. See, if a particle has large size, then it will have surface area very less. If it has size smaller, then surface area will be more. And when a particle has more surface area, it will also show its physical properties more, yes or no? Like solubility. solubility, dissolution also more. Solubility also more, dissolution also more. So what will happen? Ultimately, when we will take that drug after going to the stomach, so after this is a tablet, after going to the stomach, this will dissolve in more proper way, yes or no? So this is the stomach. After going to the stomach, it will dissolve and it will get absorbed properly. So when it will get absorbed properly, it will go to the circulatory system. When it will go to circulatory system, then distribution will be good. When distribution will be good, again it will show its action also properly, therapeutic action, good therapeutic action will be there. So that's why we need to use small sized particles having large surface area. When size is small, surface area is more, they will dissolve more better. Okay, that's why fine particle characterization is also an important property or important phenomenon which is studied which is done before the formulation of a substance. So it is also studied in the pre-formulations. Okay, next important property I already mentioned, Anderson-Pipit method. What is Anderson-Pipit method? What is Anderson-Pipit method? Please refer the last video. I took almost half an hour and I completely explained that in the last video. Okay, just I will tell that particle size in the suspension. Okay, next size determined by the optical microscopy and Anderson-Pipit method. Size of a substance, size of a particle, size of a particle is denoted by two methods. One is Anderson-Pipit method and another one is optical microscopy. Optical microscopy. So what is optical microscopy? It is the way or process by which optical microscopy is the process by which size of a particle is determined. Next is Anderson-Pipit method. So in GPAT 2017, this question was asked that Anderson-Pipit method is used to determine, number option was surface area, number two option surface area, size, solubility and flow property. So the answer will be size. Okay. In this, anyone can say that solubility also involved. Yes or no? Surface area also involved. Flow property is also involved. But when you will not get size in the option, definitely first option you will put will that surface area. After that solubility. Why? Because solubility is more when surface area is more, and surface area is more when size is less. So primarily we will consider that size. After size we will use that surface area, and after surface area we will use the solubility. Okay. Next most important point is that what is sieve analysis, dynamic light scattering and laser diffraction, culture current and all these things. These all things are mainly used to determine the fine particle size. Size are of two types. One is normal size of smaller particles, microparticles and nanoparticles, and the second one is fine particle. So the size of fine particle is generally determined by sieve analysis. Sieve analysis. Next one is dynamic light scattering. Dynamic light scattering. Next one is laser diffraction. Laser diffraction. Then counter current. Then high accuracy count. also use induction pipette method in these also, and optical microscopy in these also. Okay. You have to remember one important point here is that this counter current method, if the counter current is high accuracy counter can also measure shape. These all are used to measure the size. But high accuracy counter can also be measured to count shape also. Counter current and high accuracy counter are also used to measure the shape. Now shape and size we will learn a table, small table. This is very important. In this table different micro sizes will be there, and these micro size will have different types of powder particles and pass through the types of powder. So this tabular form is also important. It will be very much helpful for you. Okay, so different types of powder are there. One is coarse powder, COARS, coarse powder. Next one is moderately coarse powder, Next one is fine powder, Next one is very fine powder, So these are the different types of powder, and they will have 850 micron size. Moderately fine powder has 425 micron size, and fine powder has 165 micron, and very fine has also 125 micron. But what is the difference between them? See, 850 micron, it is coarse powder. 850 micron coarse powder, 425 micron moderately coarse powder, 165 micron fine powder, 125 micron very fine. Okay, very fine powder. So which one is better? Very fine powder is better powder, or coarse powder is better type of powder? Which one? Very fine powder will be better. Why? Because it has only 125 micron, so it is smaller in size. When it will be smaller size, again the same thing, surface area will be more. When surface area will be more, solubility will be more, dissolution will be more, and it will be better for further pharmacokinetic and pharmacodynamic activities. Okay, now you have to remember 100% particle pass through, that is 20. In this 120, these 2 points are very important, 20 and 120. They are not even asking the size also. 125, 165 and 850 micron size, these size are also not asking. But once they ask this 120 and 20, what is that? 100% particle pass through. That means in sieve tube, what is happening? The small in the tube, there is a tube like this. Inside this tube, small sieves are prepared like this. Okay, through this sieve, how many particles are passing? So this is sieve tube. Inside, through this sieve tube, how many particles are passing? That's important. So if 20 particles are passing, that means it is larger in size, and if 120 particles are passing, then it is smaller in size. More smaller, yes or no? So that means we have to remember that 120 particles when passed through the sieve passes, it is called very fine particles, very fine powder, and when only 20 particles are passing, it is called coarse powder. Okay, so we have to remember this too. Now we are proceeding towards the surface area and side of the particle. So what is surface area and what is particle size relation? I just mentioned few minutes ago that when size is larger, surface area is less. When size is more, surface area less. When surface area less, size is more. That means surface area is inversely proportional to particle size. Inversely proportional to particle size, yes or no? Surface area is inversely proportional to particle size, which is determined by bet and get absorption. Again, bet is coming. Already few minutes ago I mentioned about this bet. Yes, Alma, surface area is directly proportional to solubility, but surface area is inversely proportional to particle size. Okay, when surface area is more solubility, definitely, already I have mentioned few minutes ago. Can anybody tell me what is bed test? Bed test. Very, very important topic, bed test. This bed test is done to, you know what is bacterial endotoxins? Endotoxin. And what it is related to? It is related to pyrogen formation. What is pyrogen? If you break that word pyrogen, pyro means pyrexia. Pyro comes from pyrexia, which means temperature in body. And gen means generate. So pyrogen, what does pyrogen do? It's generate pyrexia. Oh, sorry. Pyrogen generates pyrexia in the body. So normally when we are getting fever, why this fever are taking place? Normally people says that the bacterial viral fever and all these things. So why this fever takes place? Due to the endotoxins only. Due to endotoxins. Endotoxin means, for example, this is a bacteria. Okay. In these microtubules, nucleus, nucleolus, mitochondria, all these things are there. Okay. So this is a bacteria. So inside the bacteria, toxin substance will be formed, and this bacteria will expel out this toxin substance inside the human body, mainly in the GIT. Mainly in the GIT, and which will later generate the pyrexia inside the human body. That is, it will cause heat generation inside the body. Okay, so this bed test, bacterial endotoxin test, we will study in the after next 2-3 topic. We will study that after completion of aerosol and that tablets and all these things. We will start this bed test and all these things. Okay, so what is gas adsorption? Surface area. Surface area is denoted by one, air permeability. Air permeability, and second is bed or gas adsorption. So what is this bed? I just told you about bacterial endotoxin test just to relate it, because already one mistake, I have seen one mistake in the test about this bed and that bed. This bed is about Bronner's Emmett test. Okay, so it is called BRAWNES, Bronner's Emmett Taylor. It is the scientist name. Bronner's Emmett Taylor is the scientist name. It a technique. Scientist name was Bronner's Emmett. So it is a technique used in the BAT equation. So what is BAT method again? BAT method is, already I wrote here, gas adsorption will be measured. So in this you will take two different types of gases. One is nitrogen, another one is krypton, or any kind of so okay, I'll tell you. These gas are the gas should be inert gas, which is less reactive. So number one is nitrogen, and second is inert gas like helium, neon, argon, xenon, radon. Neon, you can use helium also, you can use xenon also, you can use krypton also. But krypton is used most widely used gas is krypton. So normally what are the inert gases? Hina, Nina और करीना का एक्सरे रंगीन है. So helium, neon, argon, krypton, xenon, radon. Okay, these are the inert gases. So they are less reactive in the environment. So we will use krypton here. Nitrogen and krypton. Radon is radon is not used. I think I didn't get any radon, but I got helium, xenon, and krypton. Most widely used inert gas is krypton, and then nitrogen is used because it is cost effective. It is less costly. Okay, but krypton is little bit costly. That's why nitrogen is used. Otherwise, mainly krypton is used. Okay, this so the important point here is this one only, nitrogen and krypton, which are the gases used in the bed test. So the gases which are used in the bed test are number 1 inert gas and number 2 nitrogen. Less reactive gas should be there. So inert gas, again inert gas is krypton, helium and xenon. Krypton, helium and xenon. Remember that. Please repeat after me. Krypton, xenon and helium, and nitrogen is used. Why? Again, if anyone asks why nitrogen is used mainly, so nitrogen is used because it is cost effective. Okay, and second point is most important, that this nitrogen is non-porous solid. It is non-porous solid, whereas krypton, xenon and helium are porous solid, porous in nature. Okay. So in bed test, bed technique, two different types of gas are used. What are they? Number 1 is nitrogen, and number 2 is helium, xenon, krypton. Now these are non-porous, and this nitrogen is porous. Okay, so this is nitrogen is non-porous and helium, xenon and krypton are porous. So these porous solids are more costly. They are costly, and this nitrogen is less costly. That means cost effective. For physical advantage it is used, as it is non-porous, and for what it is called, less cost also it is seen. So less cost is more important here. What is air permeability method? So what did we learn in the Brunner's Emmett-Taylor test? In the Brunner's first of all, Brunner's Emmett-Taylor technique is used for what? It is used for determining surface area. Brunner's Emmett-Taylor test is used for determining surface area. Okay. In this, which principle is used? Gas adsorption. Already in the starting of the lecture I have mentioned that when liquid will be there, two different liquid will be there. At that moment, what will be used? Partition coefficient. But when solid and liquid or solid and gas is there, adsorption is the main principle. So in the case of solid and liquid or solid and gas, adsorption is the main principle. In the case of liquid or liquid gas, partition coefficient is the main principle. That's more important. And here in the bed test we are using solids. Which type of solid? Non-porous and porous solid. What are non-porous solid? Nitrogen. What are porous solid? Inert gas. What are inert gas? That is krypton, xenon and helium. Out of that, krypton is most widely used. So they are non-porous. That is porous. Okay. So these two, the name of these chemicals are important in bed test. Okay, that's important. So what is the principle? Gas absorption. And what are the gases? Non-porous is nitrogen and porous are krypton, xenon and helium. So that's all about the measurement or determination of surface area. It is test 1 bed. Again test 2 is air permeability method. So air permeability method. In this air permeability method, what will happen? It will define Kozni-Karman equation. What is Kozni-Karman equation? I think I have mentioned in the I mentioned earlier in the last in the morning. I think did I mention something about log x equals to m to the power f into t2 minus t1 upon t1. Did I mention something like this? T2 minus t1 upon t1 and log x equals to m to the power f. No response. Okay, we will learn Kozni-Karman equation later. First, let us complete that shape. So shape is determined by two types. One is scanning electron microscopy, another is transmission electron microscopy. So surface area is mentioned by bed test. Surface area is mentioned by bed test, which can also which test can measure the size. Size of particle is measured by optical microscopy. And also another person's name I told, Anderson. Why you people don't remember Anderson pipette method? Anderson pipette method. So size is determined by optical microscopy and Anderson pipette method. Surface area is measured by bed test. Okay, and air permeability. And again shape is measured by or determined by scanning electron microscopy and transmission electron microscopy. Scanning electron microscopy and transmission electron microscopy. Okay, scanning electron microscopy and transmission electron microscopy. So these three are most important in these bulk properties. Okay, so size is mentioned. Size is determined by optical microscopy and Anderson pipette method. Size is determined by optical microscopy and Anderson pipette method. Surface area is determined by bed test and air permeability test. And shape is measured by SEM and TEM. SEM. So what is SEM? SEM is scanning electron microscopy, and what is TEM? TEM is transmission electron microscopy. Okay, SEM is scanning electron microscopy, TEM is transmission electron microscopy. Okay, please repeat after me. So size of particle is measured by optical microscopy and Anderson pipette method. Surface area is measured by bed test and air permeability test. Shape is measured by SEM and TEM. What is SEM? SEM is scanning electron microscopy, and what is TEM? TEM is transmission electron microscopy. Scanning electron microscopy and transmission electron microscopy. Okay, that's it. That's most important. These are the 4 points. In this, again, in the bed test, what are the reagents used, like nitrogen and that inert gas. Okay, yes or no? Okay, again shape and surface area. What is the relation between shape and surface area? Shape and surface area both are determined by quanta solved. Okay, density. Do you know what is the unit of density? Okay, density is mass by volume. Volume means L into L into L, so L cube. So volume is all about L cube in the case of area, like this. But if it is in the case of liquid, then volume will be determined by ml and mass will be determined by gram. So density of unit of density is gram per ml. Okay, so why this liquid is related to the volume? Can anyone tell me? Did you ever get cc? What is cc? Cc is cubic centimeter. What is cubic centimeter? See, 1 liter liquid contains 1000 ml. That means 1000 ml made up of 1 liter is made up of 1000 ml, and again 1 liter contains 1000 ml, and again 1000 ml is fitted in centimeter cube. Like, how do I tell you? See, milli, centi, deci, meter, deca, hecto, kilometer. Okay, so 10 millimeter means 1 centimeter. Again 10 centimeter means 1 decimeter. Again 10 decimeter means 1 meter. Again 10 meter means 1 decameter. Again 10 decameter means 1 hectometer. Again 10 hectometer means 1 kilometer. Okay, so in this, if you see that this 10, I will make it easier, wait, 100,000 milli 1000 milliliter means 1 liter. Again 1000 liter means 1 kiloliter. In the same way, 1 millimeter means 1000 millimeter means 1 meter, and 1000 millimeter means 1 meter, and 1000 meter means 1 kilometer. So kilometer and kiloliter all are related. How? When 1 liter contains 1000 ml, in the same way 1 meter contains 1000 millimeter. That means millimeter and milliliter are related to each other, liter and meter are related to each other, 1 kiloliter and 1 kilometer are related to each other. That's why we can say, after measurement, already experimentally it is measured, that 1000 ml is fitted in 1 cubic centimeter. Cubic centimeter means 1 centimeter cube, and 1 centimeter cube means L into L into L. Already I have mentioned few minutes ago. L means centimeter into L centimeter into L centimeter. So 3 centimeter multiplied means centimeter cube. So this centimeter cube is denoted by cc, and this cc is again denoted by 1000 ml. Okay, so 1000 ml means 1 liter, which is denoted by 1 cubic centimeter. That's most important for numerical purpose. For numerical purpose it is important. Okay, next we are going to learn about different types of density. So how many types of density are there? There are mainly 3 types of density. What are they? One is called bulk density, one is called tape density, and one is called absolute density. Absolute density is also called 100% density. Okay, bulk density, tape density, gas absolute. Okay. The density is determined by, there are three types of density. Bulk density. Bulk density means when you will take a container. In this container, if you are taking 100 ml of liquid, along with inside this liquid, if particles are there, the overall liquids are called bulk density. The density of the overall liquid is called bulk density. In this, what happens that in interparticular space or voidal pores will be there. Okay, if you remove the 100 ml and if you put all the drugs here, inside this some volume and spaces will be taped. So from 100 it will become 80 ml. In this, the density, in this the liquids which are taped inside these particles, that are called taped volume. And when mass by volume is done, it determines the taped density. It determines the tape density. And number 3, absolute density. Okay, in this what will happen, the interparticle space will be there, and inside this space, if you exclude the interparticular space, see, if you exclude the interparticular space here, then you will find only 50 ml. Here it was 80 ml, and here it is only 50 ml. Okay, so either it is gas or it will be liquid. Okay, so inside this density, 100 by 50 means 2 gram per ml. So this will be the more dense, and in this the liquid will be very less. Okay, so in this density is 2 gram per ml. Here density is 100 by 80, and here density is 100 by 100. 100 by 100 means once, here 100 by 50 means 2, and here it will be in between 1 and 2, it will be 1.2, like this. So this is called tape density, this is called bulk density, this is called absolute density, and this is most important for the formulation of the drugs. That absolute density. Okay, next, it is determined by the most important point here is that helium cyanometer and mercury porosimeter. So helium cyanometer, and number 2 is Hg porosimeter. So these two determined by these things. Okay, so the time for live was 1 hour, and the time is completed. Now live will stop automatically. Okay, so thank you very much for your cooperation, and have a wonderful day.